Hi guys, it's me again, and I want to talk about significance testing for a difference in proportions. All right, so the conditions here are the exact same as the conditions that we just reviewed for the confidence intervals. So essentially you're going to be checking conditions on both distributions to make sure that it's okay to move forward. All right, so now we're actually going to be talking about testing. This is where we're going to be coming up with a p-value so that we're able to compare our p-value to an alpha level. And so we're working in proportions, so that means we're going to be talking about z. So here is the formula to calculate your z value when you're looking at a difference in proportions. So we're going to have p hat 1 minus p hat 2. Now what you see down here is this little p hat sub c. Let's talk about that. This is what is called a pooled proportion. And so here's how you calculate it. You take the total number of successes in both of the samples combined, and you divide that by the total number of individuals in both samples combined. All right, so this is how we calculate a pooled proportion. Once you see this sort of in practice, it becomes a little clearer. Sorry, I'm trying to straighten out my camera as best I can. All right. Feel free to pause me as much as necessary to get this stuff written down. I might be going a little bit quickly. All right, so if we're going to be running a test, that means we're going to need a hypothesis statement. The null hypothesis is always the same when you're talking about a difference in proportions. So the null hypothesis is always going to be that P1 minus P2 is equal to 0. Or alternatively, this is exactly the same thing. You can write P1 equals P2. Right? These two statements say the same thing. This one says if I subtract them I get 0. This one says P1 is equal to P2. Same thing. Okay, so your null hypothesis is always going to look like one of those two things. Pick the one you like better, it doesn't matter to me. All right, your alternative hypothesis, again, we can have three different versions of an alternative hypothesis. We can have the two-sided, which would be in one case that when you subtract them, it does not equal 0, or P1 does not equal P2. Again, these two things are equivalent to one another. Or you could have a greater than, or you could have a less than statement, right? So it's going to be one of these three options depending on the wording of the problem, and then you just sort of like pick your preference here for whether you like to write them in terms of 0 or compared to one another. So again, feel free to pause if you need to take a couple of minutes and write some of that stuff down. And I'm going to move into an example. Sort of see what this looks like. All right, here goes. So here's our example. We have researchers that are designing a study. They want to compare the proportions of children who come to school without breakfast at two different low-income schools. So here's the deal. They take an SRS of 80 students at school 1, and 19 of them had no breakfast. So I took my calculator and I found that first proportion. 19 divided by 80 gave me this 0.2375. In an SRS of 150 in school 2, 26 had no breakfast. So again, I calculated that proportion. 26 divided by 150 gave me this 0.1733. All right, so let's talk about this for a minute. Clearly, in this one sample, the proportion of students without breakfast was higher at school 1. But remember, this could have just been due to sampling variability. If I took a different sample, I might have gotten different results. And so the question is there a statistical significantly difference between these two proportions? So let's get going here. Let's state our situation. We want to test. Remember, the null hypothesis is always going to be 0, that P1 minus P2 equals 0. And they're just saying just a difference. They didn't say greater at 1 or less than at 1. They just said a difference. So our alternative hypothesis is going to be that the difference does not equal 0. Again, if you prefer, you could have written P1 equals P2, and then P1 is not equal to P2. Those are exactly the same as the way that I've written them originally. And over here, we'll define our variables, where P1's the true proportion who did not eat breakfast at school 1, and P2 is the true proportion who did not eat breakfast at school 2. So our plan is going to be to perform a 2-sample z-test. This is what we're doing, a 2-sample z-test for P1 minus P2. So in our planning stage, this is where we check our conditions. So remember, I'm going to check conditions for both distributions. They're both SRSs. Each sample is no more than 10% of the population, because they say up here that each school has more than 1,500 students, so I'm good. And then we have to check like all 4 of these guys. I didn't actually type them in the calculator, but you should. You're going to check them all and make sure they're all greater than 10, so you're going to do that, and they definitely are, so I'm not concerned. All right, so I've stated my hypothesis, I am forming a plan, I've checked conditions, and I'm feeling good about moving forward. So I'm going to get P sub C, which is my pooled proportion. So I added my 19 and my 26 in the numerator, right? It's the total number of successes. At school 1 it was 19, at school 2 it was 26, over the total number of students that were surveyed, which was 80 plus 150, and my P hat sub C is 0.1957. So here comes my calculations for Z. I'm subtracting P1 minus P2 divided by the pooled P value times 1 minus it over N1, and again the pooled value times 1 minus it over N2, and I have now a Z-score of 1.17. So we are going to look up the 1.17, but remember, this is a 2-sided test, so I have one of 2 choices. I can look up negative 1.17 and directly take that proportion and multiply it by 2, or I can look up the positive 1.17, subtract the proportion of from 1, and then multiply by 2. So I'm going to go the first route. I'm going to do 2 times the probability that Z is less than negative 1.17. So from the table, I got 0.1210, and I've multiplied that by 2, and I now have a p-value of 0.2420. That is not a very good p-value, especially because we were looking at an alpha level of 0.05 in the original problem. So here comes my conclusion. With a p-value of 0.2420 at an alpha level of 0.05, we fail to reject the null hypothesis. There is not evidence that the proportions of students who do not eat breakfast is different at the 2 schools. And there it is, my 4-step process. All right, so you're going to be receiving a packet that has some examples, and let me grab one and plop it under the screen here. And honestly, there's probably not enough room on the packet for you to do the 4-step process for these problems, so you really might want to get some lined paper out. So you're going to be getting this paper here, all right? And so I'll start you off on this first scenario. So we want to know, let's see, middle-aged men were assigned at random to one of 2 treatments. We have some men that took this drug, gemfibrozil, and a whole bunch of other guys took a placebo, and then they're telling us how many in each of the groups had heart attacks. And so we want to see at a 1% alpha level if there is actually a difference between the heart attack rate. All right, so you need to find P sub 1 hat and P sub 2 hat. You're also going to want to find P sub C hat. Remember that the four-step process is going to look similar to the problem that I just did. So you're going to start off with stating the problem. You're going to form a plan where you check your conditions. We are going to actually calculate a z value, and then you're going to draw a conclusion. So use the first example as a guide, and I will tell you that ultimately for this problem, after you've done all of your work and you get a p-value, I'm going to tell you what the p-value is now. Ready? I'm not going to do it all out because I want you guys to practice that. I'm going to tell you that your p-value should be 0.007. All right, so that's like what you're striving for at the end. And we have another example here. It's going to be really similar. This problem also wants you to construct a confidence interval, so that goes back to the previous video. And so you're just going to work through these problems the best you can, making sure to follow the four-step problem-solving process for each of them. All right, that is your task, and I will see you guys on Thursday. All right.